Need to expose custom tools to AI models like Claude, but don't want to deal with complex API setups? You'll see how to create a complete FastMCP server in under 15 lines of code, including a working dice rolling tool that AI can call directly. We'll deploy it locally, then connect it to Anthropic's Messages API, all with minimal boilerplate.
Import random. From FastMCP, import FastMCP. MCP equals FastMCP. Name equals dice roller. At MCP, tool. Def roll dice, end dice. Int list int. Roll end dice, 6-sided dice and return the results. Return random. Randint 1/6 for in range end dice. If name equals main. MCP. Run transport equals HTTP. Port equals 8000.
This demonstrates the AI tool integration pattern, where Python functions become directly callable by language models through a standardized interface. The decorator-based approach transforms regular functions into AI-accessible tools while preserving their native Python behavior, creating a seamless bridge between human code and machine reasoning. What makes this distinctive is how it maintains clean separation between your business logic and the AI integration layer, with no framework-specific code polluting your core functions. The pattern works by leveraging Python's decorator system to register functions as tools while the framework handles all transport, serialization, and discovery automatically. Your decorated functions remain pure implementations, while the framework generates open API-compatible schemas from type hints and exposes them through a standardized endpoint. This declarative approach means you define what your tools do, not how they're accessed, enabling the same code to work across HTTP, WebSockets, or direct SDK integrations without modification. This approach solves the critical problem of AI tool integration complexity, eliminating the need to manually build and maintain API layers just to expose functionality to models. It's particularly valuable when building AI assistants that need to perform deterministic operations, query databases, or interact with external systems. The trade-off is minimal. You gain immediate AI interoperability at the cost of following simple type hint conventions, making it ideal for rapid prototyping and production systems alike. Let's break it down line by line.
Import random.
Imports Python's built-in random module for generating pseudorandom numbers. This provides the randint function used later to simulate dice rolls with uniform distribution across all possible outcomes.
From FastMCP, import FastMCP.
This imports FastMCP, the core class for building AI callable tools. It transforms regular Python functions into structured tools that AI models can invoke with proper type safety and documentation.
MCP equals FastMCP. Name equals dice roller.
Instantiates the FastMCP server with the name dice roller. This name identifies the toolset when exposed to AI models, enabling clear routing and logging. The instance becomes the central registry for all at MCP tool decorated functions.
At MCP, tool. Def roll dice, end dice. Int list int. Roll end dice, 6-sided dice and return the results.
This decorator exposes roll dice as an AI callable tool through FastMCP. The type hints and docstring automatically generate the tool's schema, defining input validation and documentation in one place.
Return random. Randint 1/6 for in range end dice.
This is a list comprehension that generates end dice random integers between 1 and 6, simulating dice rolls. The underscore discards the loop variable since we only care about the count, not the iteration value. This pattern efficiently creates the result list in a single readable line.
If name == main.
This is Python's standard entry point guard. It ensures the server only starts when the script runs directly, not when imported as a module. Without it, importing this file would automatically launch the FastMCP server.
MCP, run transport = HTTP, port = 8000.
This launches the FastMCP server on HTTP port 8000. The transport parameter defines the communication protocol, while port specifies where the server listens for incoming AI tool calls. This is the standard entry point pattern for FastMCP services. FastMCP tool decorator pattern. The MCP tool decorator transforms ordinary Python functions into AI callable endpoints, automatically generating schemas and handling type validation without additional boilerplate. The tool's docstring becomes its public interface, so write it for both machines and humans. This single decorator bridges the gap between local Python logic and distributed AI systems.
The decorator that names the tool becomes nameless in the call.